I am Anitha Kripanidhi, Assistant Professor of Chemistry at Marri Reddy Institute of Technology and Management. And in the last class, we have discussed about mechanism of free radical addition polymerization. In continuation with the class, today we'll discuss about condensation polymerization from polymeric materials chapter. So today we'll see about the polymers. From the polymers, it is condensation polymerization. In the last class, we have discussed about what is meant by polymerization and what are the types of polymerization. And here the types are addition and condensation. So in the last video, we have covered the addition polymerization. So today we'll see about condensation polymerization. And next, what are the main characteristics to take place this condensation polymerization, that we will see. And the next one is the types or the two classes of polymers, that is polyesters and polyamides under this condensation polymerization. So first we'll see about what is meant by polymerization. So here already we have discussed that it is what is meant by polymerization, and here the two or more monomers, they combine and form a long chain of polymers of high molecular weight or the three-dimensional structure. Okay, so that is called as polymerization. And next, this polymerization occurs via different reaction mechanisms which are affected by the factors like functional groups. That means what are the different types of functional groups are attached to the carbon chain of the polymer. And one more factor is the non-bonding interactions. So non-bonding interactions means there is no exchange of electrons or the free radicals takes place. Okay, so that is called as the non-bonding interactions, like van der Waals forces, van der Waals interactions, hydrogen bonding, ion-ion interactions, and the dipole-dipole interactions. Okay, so these are called as the non-bonding interactions. Now in this polymerization, there are two types are there, that is addition and condensation polymerization. So this addition we have covered already. Now in today's session, we will see about condensation polymerization. So what is meant by condensation polymerization? Okay, so in this what is meant by condensation polymerization means here it is a step growth. Okay, so it is a step growth polymerization where small molecules is nothing but what? These are nothing but monomers in this polymers, right? So these monomers, they react with each other to form a large structural units with the elimination of the small molecules like water or the alcoholic molecule or CO2, etc. Okay, so that means overall what is here condensation polymerization, the same polymerization reaction takes place with the elimination of the byproduct. Okay, so with the elimination of the byproduct, so here these are the byproducts are normally referred to as condensate. Okay, so here the byproducts what releasing in the chemical reaction, those are called as condensate. That's why the name of the reaction is the condensation, and here it is polymerization reaction. That's why it is called as a condensation polymerization. Okay, now if you see the reaction, you can understand better. So this is one monomer and this is another monomer, and here it is if you observe here, these are the small molecules are there. So here condensation polymerization means the two monomers, they come and linked with each other. But for this linking, what happens, there are some atoms or molecules which are blocking the linkage. Okay, which are blocking the linkage here. So the atoms are blocking the linkage. That's why in this chemical reaction, what happens is these byproducts are eliminated. When the atoms which are blocking the linkage, these atoms, they get eliminated out, then the two monomers, they come and linked with each other. Okay, so here these are the atoms which are blocking the linkage, so this will be eliminated here. So here it is the eliminated or the joining groups, and next these two, they combine and forms a dimer. Okay, that is the polymer. Now for this step growth polymerization, it grew by how this step growth polymerization takes place means the carbon and heteroatom. So if you see the addition polymerization, there we have discussed with an example. There, if you observe there, all the along the polymeric chain, the carbon atoms are attached. That is, all the atoms are similar. Okay, but here, whereas in the case of step growth polymerization, this carbon is attached to either with oxygen or the nitrogen or any other, or sulfur or any other hetero atom. Okay, so carbon is attached to any hetero atom, then the condensation reaction takes place. Okay, so here examples are, the examples of naturally occurring condensation polymers are cellulose and the starch, cellulose, starch, and then proteins, and then if you take DNA. So all these, in all these structures, carbon with heteroatom will be present. Okay, so these are the examples for the condensation polymerization. Now here the two main types of condensation polymers are polyesters and polyamides. Okay, these are the two main classes of this condensation polymerization. Okay, so now we'll see what is meant by polyamides and polyesters. So before going to the polyamides and polyesters, before discussing all those chemical reactions, first we'll see what are the main characteristics of this condensation polymerization. Okay, so to occur a reaction, the molecules should have, these are the main characteristics of the condensation polymerization. Clear? So what are they means? They should have one or two functional groups. Okay, one or two functional groups, like two alcoholic groups attached with to the carbon, two alcoholic groups, or the amine group, or the carboxylic acid groups. These any two functional groups are attached to the monomers. Okay, so here when you come to the functional groups, once again, this when both the functional groups suppose it is one monomer. To this monomer, if both the functional groups are OH groups, or to this monomer both the functional groups are COOH groups. Okay, so like this, both the functional groups are attached, that means, or the similar, then what happens is, in this condensation product, a linear polymer is formed. Okay, so if both the functional groups are attached here, both the functional groups are difunctional. That means in this this is the monomer and it is the difunctional group. That means two functional groups are attached to the system. That means the monomer. Okay, so that's why what happens? What type of polymer is formed means a linear polymer is formed. Okay, so to the monomer, if two functional groups are attached, then a linear polymer is formed, and more than two functional groups, or that is three or four, tri or tetra functional groups are attached to the monomer, then what happens? It leads to the formation of a cross-linked polymer. So the best example for the cross-linked polymer is the bakelite. Okay, clear? Yes. So these are the few main characteristics of the condensation polymerization. Now we'll see the two important classes, or two important types of condensation polymerization, that is polyamides. Okay, so in this polyamides, what is meant by polyamide? So poly means already you know the meaning. Poly means because it is a polymer, that means a chain is there, that's why it is called as a poly. And next, amide means, what is the functional group of amide, students? So it is the functional group CONH2. Okay, so here CONH2, it is the, if CONH2 is there, this functional group is called as a amide group. Clear? So these polyamides are synthetic or natural polymers. They arise, how these amide group is formed means by the condensation reaction of the carboxylic acid and the amine. Okay, so what is the carboxylic acid functional group? Carboxylic acid means COOH, and amine means NH2. So when the reaction takes place between these two carboxylic acid and amine group, then it leads to the formation of what? It leads to the formation of a polyamide. That means that is the amide, okay, CONH2. So they are made up of amide groups. In the polyamides, this amide group, that is CONH2 group, this amide group, this group will be repeated in the chain, okay. In that polymer chain, this CONH2 group is repeated, okay. What is the repeating unit in this polyamide? Means you have to tell that it is the amide group, okay. So that's why it is called as a polyamide, and the examples are the nylon and proteins. And this nylon is nylon is considered as a polyamide. Why? Because it has 85 percentage of amide linkages, okay. Now we'll see the preparation of this nylon, and here this nylon is it comes under the class of polyamides, okay. Remember this one, it is the nylon, means it comes under the polyamide. And this nylon, mainly in the previously, first it has synthesized in the New York and London simultaneously, okay. So after the two cities, it is named as nylon. So nylon means here NY means New York and LON means London. So after the two cities, it is named as nylon. And these nylons comes under the class of polyamides. And there are different types of polyamides are there. There are different types of polyamides. That means nylons are there. That is nylon 6 and then nylon 66, nylon 610, like this different classes of nylons are there. Now in your syllabus we have the nylon 66. Now we'll discuss about nylon 66. So here nylon 66, what is the meaning of the nylon? Just now we have discussed, okay. So nylon means what? It is the nylon means based on the after the two cities, it is named as a nylon. And next, what is the meaning of this 6,6? Okay, now we will see that one. So how this nylon 66 is formed means it is formed by the condensation reaction of hexamethylene diamine, okay. So what it is means, it is hexamethylene diamine. Hexa means what? It is the number, what? It is the 6. And next, methylene, what is meant by methylene, students? Methylene means CH2, okay. So how to write the structure? Methylene means CH2, hexa means 6, that's why CH2 taken 6 times, okay. So it is named as the hexamethylene. And next, amine, what is the functional group of amine? NH2, okay. How many amine groups are there here? 2 amine groups, so it is the diamine. So how to write the structure? This side one NH2 and this side also one more NH2, clear? So for the preparation of this nylon 66, first we have to take the hexamethylene diamine compound, and next one is the adipic acid. It is named as adipic acid, but when you see the IUPAC name of the adipic acid, it is tetramethylene dicarboxylic acid. Okay, so methylene means CH2. Tetra means how many? 4. That's why CH2 taken 4 times. And next, carboxylic acid. What is the functional group of carboxylic acid? COOH, right? So how many carboxylic acid groups are there? 2 carboxylic acid groups. That's why it is named as the dicarboxylic acid. So now see the structure here. CH2 tetramethylene, CH2 taken 4 times, and then here it is COOH, and this side also COOH, okay. Now this point we can apply for the characteristics of condensation polymerization. There we have discussed one point, that if the monomer is difunctional, okay, if the monomer is difunctional, that means 2 functional groups are attached to the monomer, then it leads to the formation of what? It leads to the formation of what type of polymer? It is linear polymer, okay, not the cross-linked polymer. So in this case, the linear polymer is formed. So now we'll see how this linear polymer is formed. So here it is a condensation reaction. So that's why what is the main point to remember? It is the elimination of the water molecule takes place, okay. So from here, it is from here OH group, and from this NH2 one hydrogen, Okay, from this NH2 means two hydrogens are there here. From these two hydrogens, one hydrogen comes out. So here these are the two atoms which are blocking the linkage. So that's why these two are eliminated as a water molecule. Okay, when the water molecule comes out as a byproduct, then immediately the two monomeric chains, they come and attach with each other and forms a polymer. Okay, so here minus H2O. So like this H2O is released out. H2O. Okay, so H2O releases out or that comes out. Then if you observe here, in this reaction, what is the repeating unit here? After the condensation polymerization reaction, what is the, if you see the structure of this linear polymer, what is the repeating unit present here? Here it is NH is there, and here it is the CO is there. That's why this C double bond O NH is written here. Okay, so C double bond O NH, the C double bond O NH is what it is named as? It is named as amide, right? So that means in this polymer chain, again hydrogen from NH2 and a OH group from carboxylic acid, they combine and releases out. Okay, so it releases out and forms the polymer. In this polymeric chain, what is the repeating unit here is the amide. That's why it is named as a polyamide. So nylon 6, the formation of nylon 6,6, it comes under which class of condensation polymer? Means it is a polyamide. Now we'll see the uses of nylon 66. In this nylon 66, it is fabricated into sheets, and our day starts with nylon 66, right? Why? Because here the bristles of this toothbrush, it is for the preparation of this bristles of toothbrush, nylon 66 is used, and it is used in the textile industry. So now another class of condensation polymers we will see, that is the polyester. So in the polyamide, the repeating unit is what? CONH, that is the amide group. And here in the polyesters, what is the repeating group? Is the ester group. Okay, so this ester group, it is repeated in the polymeric chain, so it is called as a polyester. Okay, so what is the group is repeated? Ester means what it functional group? RCOOR. Okay, so this is called as a ester group, and this ester group, it is present in the backbone of the polymeric chain, or the main structure. It belonging to the most important polymeric materials. So how this polyester is formed? Okay, with the reaction of what? That means with the reaction of the diacid and dialcohol. So here with the reaction of diacid means here it is nothing but the carboxylic acid. Okay, so dialcohol means it is the alcoholic group is there, that is the OH group. Now here also one characteristic of condensation polymerization we can observe here, that is what here also this monomer is having how many functional groups, students? Here also it is the difunctional. Okay, this monomer is difunctional and this monomer also difunctional. If the monomer is having the difunctional group, then it leads to the formation of what type of polymer? It is the linear polymer. Okay, if more than two functional groups are there, then it leads to the formation of the cross-linked polymer, which is nothing but the best example is the bakelite. Okay, yes, now we'll see here it is the from carboxylic acid group and the dialcoholic group, it is water molecule is eliminated, and it leads to the formation of a polyester. Now we'll see the reaction. We'll see the reaction of this one, that is formation of terylene, and the example for this polyester we are discussing is the terylene. This terylene is also called as Dacron. It is a saturated polyester. It is also known as terene or terylene, whatever. Okay, and this terylene polymer, it is formed by the condensation of ethylene glycol and the terephthalic acid in the presence of a weak base like calcium acetate. Now we'll see this reaction, how this terylene is formed, that is how this polyester is formed in the reaction. Now we will see. So with the reaction of the ethylene glycol and the terephthalic acid. So in this ethylene glycol, what is the structure of ethylene glycol? Here it is the CH2OH, CH2OH and then CH2OH. That is, here it is 1,2-ethane diol also we can tell, that is the IUPAC name. Ethylene glycol, two alcoholic groups are present here. Okay, so this monomer is having how many functional groups? That is the two alcoholic groups. And next one is the terephthalic acid. This terephthalic acid is also known as benzene dicarboxylic acid also we can say, that is the IUPAC name. So just here it is the benzene ring is there, and here on both the sides a COOH group is present. Okay, so these two reactions, one monomer is the dialcohol and the another monomer is the diacid. Okay, when dialcohol and diacid, if these two monomers react with each other, by the elimination of a byproduct, that is the water molecule, it leads to the formation of a polyester. Okay, so in that polyester, the repeated linking unit is what? That is the ester group. So here also OH group, here OH group, and then hydrogen from here, these two are eliminated. These two are eliminated as a water molecule. Okay, these two are eliminated as a water molecule, and then it in the presence of a weak acid or base, and then it leads to the undergo condensation polymerization and leads to the formation of a polymer. In this polymer, here it is ester bond is we can observe here. Okay, what is the ester bond? Ester bond is what? RCOOR. Okay, in the place of R, this chain we can think like this, and next here RCO, this is one more R, and in the middle is the COO. So this is called as the ester bond. In the terylene, what is the repeating unit? In the terylene polymer, what is the repeating unit, students? It is the ester bond. Okay, in the nylon it is the amide bond, and in the terylene it is the ester bond is the repeating unit. Okay. Now we'll see the properties of this terylene. This terylene, it absorbs very little amount of water. Okay, so because it is absorbing very little amount of water, it dries up quickly. Okay, it dries up quickly and it can be washed easily. And this terylene cloth or the Decron fabric, it is resistant to acids and bases. Okay, due to its insolubility of most organic solvents. And terylene is resistant to friction. It is resistant to friction also because of its high tensile strength. And terylene, it is a synthetic polyester fabric that in mixing with the wool, when terylene is mixing with wool, then it is called as a terrywool. Now we'll see the uses of terylene. It is used in making plastic bottles, and it is also used to make hardware cloths like hard cloth. One is tapestry. Here tapestry means this is the fabric here, and this which means that it is a very thick cloth with images. Okay, it is a very thick cloth with images, that is called as a tapestry, which is made from terylene. And then fleece jackets. Okay, these are the fleece jackets and dress materials in various textile industries. And it is used, this fiber is used in the preparation of polyester tricot knitted garment. That is, knitted garment means like this, like small holes will be present, which is called as a polyester knit as a fashion garment fabric. Now, in today's class, we'll conclude the topic, that is condensation polymerization. Here, we have discussed about polymerization, what is meant by polymerization, and what are the types of polymerization. There are two types of polymerizations are there, that is addition and condensation. So, in one video, in the previous video, we have discussed the addition polymerization and mechanisms of free radical addition we have discussed, and in this video, we have discussed about condensation polymerization. Okay, so and condensation polymerization and the examples, two examples or the two classes of condensation polymers we have discussed, that is nylon 66 and terylene. These are the few references for this topic. Thank you.